Hello and welcome to DeveloPerSpective. So today we will be speaking about an interesting topic, and that would be on message queuing technology. Basically, when we think about a software application, we only imagine it to have two components to it. That is the front-end code and the back-end API. The front-end code connects to the back-end API and it gets the response within a few seconds. And that is almost always the ideal scenario. But don't you think that's not always the case? There may be some processing that may take more than just few seconds. So that's when the message queuing technology makes more sense. So today we will be speaking about message queuing technology using RabbitMQ. RabbitMQ is a message broker based on AMQP that stands to Advanced Message Queuing Protocol. So to understand what message queuing is, let's speak about a scenario. So we have a feature in our application to download dump report from the web page as an Excel file. Now imagine that we have around 1 million records to be processed and inserted to the Excel to generate the final report. And it takes approximately 30 minutes for the backend service to generate that report. So every time a user tries to download a report, that HTTP API makes the user wait on the page for 30 minutes to finally get him the report he wants. Also, if in any case the connection between the client and the server is lost, then the report request fails and the user doesn't get a thing. Also, if the server by any chance gets restarted or failed to process the request, the user will never get the report he requested for. And now consider this activity is done by more than 100 users at a time. So that is the nightmare which any application will not want to have in their dreams. So to summarize, the common problems an application like this can have are long wait time, highly dependent on client and server connectivity, no failover mechanism, and extreme load on the server. So to solve this problem, the best approach we can go for is to make the process of requesting the request and the generation of the report asynchronous. So to facilitate this approach and to add failover features and many more features, we have RabbitMQ to our rescue. So what RabbitMQ does is it acts as an intermediate gatekeeper which takes requests from the users and queues it to be processed by the backend service. So now the application will work something like this. The user sends the request for the report, the application accepts that report and sends that request to RabbitMQ queue, while sending back the acknowledgement to the user about the receipt of the request. Then the user is free to use other feature of the application or can even opt to exit the application. RabbitMQ will smartly send the request one by one to the backend server and the backend service can now process it. Once the processing has been completed, now the backend can just send a notification via email or by any means to the user letting him know that the job has been completed and can go ahead and access the report. If in any chance there is any failure in the backend, then RabbitMQ will reprocess those failed requests again once the backend service comes up, hence making the process fail-proof. This is just an example of a real-life problem that a RabbitMQ can help us solve. So the goal of this video would be to understand how RabbitMQ works and what are the different features and techniques you can use to suit your needs. Also, you can find a link to the video where we have actually implemented RabbitMQ and see it in action. So do watch that video once you are done with this. You can also find a reference to that video at the end of this video as well. RabbitMQ consists of 6 modules into it. So those are producer, consumer, channel, connection, exchange and queues. So we will be exploring each one of them one by one. So the basic unit of RabbitMQ queuing process has producers, queues and consumers. A producer is anything that can create a message to be sent to the queue. It can be an external HTTP based service or it can come from any other type of protocol based service. So anything that can generate a message to be passed to the queue is called the producer. A consumer is the one which receives the message and processes it. In normal world application, consumers are software services that connect to the RabbitMQ server by means of creating a connection to the RabbitMQ through the channel. Channels are virtual connections, mostly AMQP connections within RabbitMQ, whereas a connection is the TCP connection between your application and the RabbitMQ broker. And finally, a queue is the place where the messages pushed by the producers reside. And those messages are later sent to the consumer to be processed. So the producer produces message and publishes those messages to the queue. So let's take an example of application logs. So the producer produces log and the consumer needs to print that log out to the console. So now when the producer creates a log with the text hello, that message moves to the queue and are received by the consumer, and the message hello is printed on the console. Now let's make multiple consumer attached to a queue. So now we connect two consumer to a queue. When we publish the first message, it will be received by the first consumer, and the second message will be received by the second consumer, and then this happens in a sequence. On average, every consumer will get the same number of messages. This way of distributing message is called round robin. Now, if there are a lot of messages going to each of the consumers, and one of the consumer while processing a message dies midway, by default RabbitMQ will delete the message from the queue as soon as it is delivered to a consumer. So that will cause the application to lose its messages. So to manage the failover, RabbitMQ has a feature of message acknowledgement. So every time a consumer receives a message, it has to send an acknowledgement back to RabbitMQ to let it know that the message has been received, processed, and it's free to delete. So if a consumer dies while processing a request, RabbitMQ loses connection to the consumer. The queue will understand that those messages are not processed completely, so it will re-queue and those messages are sent to other consumers who are available to process. Hence, no loss of messages from the queue. Now let's speak about Exchange. You would be surprised to hear that we have been using Exchange right from the start. Basically, a producer can never send a message directly to the queue. It has to always go from an exchange. If we are not specifying any exchange, then by default Nameless exchange is used to get messages from producer and push to queue. We will be understanding how that works further on. So basically, an exchange decides on what to be done with the messages it receives from the producer and can select the queue which should be receiving this message. There are 4 different ways through which an exchange can decide to deliver messages to a specific queue, and those are direct, topic, headers, and fanout. The relationship between an exchange and a queue is known as binding, and binding defines the way in which a queue will receive messages from the exchange, and it depends on the type of exchange associated with it. So let's quickly understand how these different type of exchanges work. So Fanout works as a broadcast. Whenever you publish a message to an exchange which has the type of Fanout, it will send that message to all its associated queue. So now all our logs will be sent to all the consumer associated with the exchange. Now if we want to send a specific message to a specific queue, so in that case we will be using a direct type of exchange. In this, we define the binding key to each of the queues, and each message sent will have a routing key. If the routing key and the binding key matches, then the message is delivered to that queue. So now let's have 3 consumers with binding keys as info, error, and debug. So messages with a routing key as info will go to info, and error will go to error, and the debug will go to debug queue, and all the other messages will be discarded. If any of the 2 queues have the same binding key, then the message will be broadcasted to both the queues. It will act as a fanout. As I specified earlier that a queue that has not defined an exchange will always be using a default exchange, or you can call it as nameless exchange. In this case, the message will be sent to the queue whose name exactly matches the routing key. Let's speak about the exchange type topic. In this type of exchange, the routing key will have a list of words delimited by dots. For instance, a more precise log will also indicate the source of its occurrence. For example, we have an error log coming from the DB code of checkout feature. So we have a routing key as checkout.db.error. In the same way, the binding key will be a list of words delimited by dots, but will have 2 extra features of star and hash. Star can substitute for exactly 1 word, and hash can substitute for 0 or more words. So let's try it out. we will have binding keys for three queues as checkout.hash, star.star.error, and star.service.star. So now we have messages sent by the producer having routing key as follows. Checkout.db.error will go to the first and second queue. Checkout.db.info will go to the first queue. Login.db.error will go to the second queue. Login.service.error will go to the second and third queue. Cart.service.info will go to the third queue. Checkout.cart.service.info will be going to the first queue even with extra words to it as it matches the condition. Login.cart.service.error will be discarded as it doesn't satisfy any binding key. There is this last type of exchange which is a header based exchange that uses header argument value instead of routing key in messages, and it works the same way as a topic exchange. This is all about RabbitMQ. There are other features of RabbitMQ like RPC and different protocol supports, management tools, and deployment configuration which can be explored to get the most out of the RabbitMQ universe. But we will stick to the functionality and working of RabbitMQ. In the next video, we will be actually implementing all the features we discussed in this video. So if you are still watching this video until now, then you should be checking out the other video as well, which you can see on the screen now. And if you found this video useful, please click the like button and don't forget to subscribe to my channel.